The next part of the question is saying that determine the acceleration vector at any point xy at any time t. Remember, the acceleration vector will be given by this. A is equal to, acceleration vector will be given by xi plus ayj. Okay, so how do we find ax? Ax is given by u partial of respect to x plus v u with respect to y plus then u t partial with respect to t. So now we have our u. What is our u? From the velocity vector here, we have 2x y power 3 over 3 minus x squared. This is our u. And our v is x y squared minus 2x y cubed over 3. So find your partial derivative of u with respect to x and y. So the first part, let's find this. This is equal to, differentiate this one with respect to x. So here the power of x is 1, so it will just be 2 y power 3 over 3 minus 2x. Then differentiating again the same u with respect to y. This is the y, so derivative of this will be 2xy squared. Then substituting it back into this equation. Well, first we also need to find our partial derivative of u with respect to t. Okay, there's not here to be 0. This is a steady flow because the variables with respect to time, they do not change with respect to time. And then now substituting back into this equation here, our ax will be given by, our u is 2x y power 3 over 3 minus x squared. Then our partial derivative with respect to u, this one here is given by this, is 2y 3 over 3 minus 2x plus our v is x y squared minus 2x y power 3 over 3 multiplied by 2x y squared. Okay, so this is the vector the acceleration component along the x-axis. You can expand and simplify this. Let's do that. Expanding this, we're going to get um, this times this. We should get 4x y power 4 over 9 minus 4x squared y power 3 minus 2x squared y power 3 over 3 plus 2x power 3. This is the first expansion here. Then plus, expanding this, we should have 2x squared y power 4 minus 4x squared y power 5 over 3. Then you can simplify according to what is common and the power 4s, so we can write okay, if I begin to simplify, the video is going to be very long, but we know, at least we've known how to obtain the first component for the acceleration. So now let's obtain now the component for the acceleration along the y-axis. This is given by u x plus v, this is v y plus v and t. So let's find v with respect to x is given by, this is our v. Differentiate this with respect to x. The first part will just be remain with y squared minus 2y power 3 over 3. Then differentiating it with respect to y, we're going to have 2xy minus 2xy squared. And substituting them in this equation, and remember v with respect to time is 0 because there's no t in v. Substituting them back, we're going to have our acceleration components along the y will be given by, what is your u? Our u is 2xy power 3 over 3 minus x squared. And then the first partial derivative is y squared minus 2y power 3 over, so 2y power 3, the over is only for this term, then plus the v is xy squared minus 2x y power 3 over 3. Then the other component is xy minus 2x y squared. Okay, so this is the other component for the acceleration. So the acceleration vector now will be given by the first component of acceleration, this one. Okay, so I'm just going to write this one. I'll write it like this. Okay, and expanded, so to be 4x y power 4 over 9 minus 4x squared y power 3 minus 2x squared y power 3 over 3 minus 2x cubed plus 2x squared y 4 minus 4x squared or 5 over 3. Then this is I plus, then here we're going to have, let me write this bracket, we're going to have 2x y power 3 over 3 minus x squared y squared minus 2y power 3 over 3 plus x y squared minus 2x y cubed over 3, 2x y minus 2x y squared, and everything is j. This is the acceleration vector for the given velocity vector field.